Hello, this lesson is on simplifying radicals. So the concepts that we're going to go over are multiplying property of square roots, division property of square roots, and how to simplify radicals. So if you multiply two square roots together, the square root of a times b is equal to the square root of a times the square root of b. So if I multiply square root of 6 times the square root of 9, I get the square root of 54. And reverse also is true. The square root of 54 is equal to the square root of 9 times the square root of 6. Now, since we know the square root of 9 is 3, we write radical 54 as 3 times radical 6. And since I can't break down radical 6 into perfect squares, I leave it as 3 radical 6. So if I did this on my calculator, radical 54 is equal to this, and 3 times radical 6 is also equal to the same value. Division property, we've done this before. If you have two numbers and a fraction underneath a radical, they could be split up into top and bottom radicals. So the radical 16 over 25 is radical 16 over radical 25, and then I could just take the square roots and get 4 and 5. So we're going to simplify radicals. There can't be a radical underneath the square root. For example, we wouldn't leave an answer as radical 4. We would say that's equal to 2. No radicals. The radicand has no fractions, meaning this would not be a proper answer. It would turn into this. And the denominator has no radicals in it. And again, you can't leave a radical in the bottom of a denominator. A radical expression is an expression with a radical in it or a square root in it. Rationalization means to rewrite in order to eliminate radicals from an expression. Rationalizing the denominator of a radical expression may be necessary to obtain simplest radical form. Okay, removing a variable factors. So we're going to simplify this square root of 28 x to the 7th. So basically, you're going to break up your radical into perfect squares. So 4 times 7 is 28, and x to the 6 times x to the first is also is a perfect, or is x to the 7th. Okay, so this is a little confusing here. And then we can say we can do the square root of 4 is 2, and the square root of x to the 6th is x to the 3rd, and square root of x to the 7th is left behind. So this is a little tricky. So basically what we're doing is taking the square root of 28, and we're saying that's equal to the square root of 4 times the square root of 7. And we know what the square root of 7 is, so we call that 2 radical 7. I can't take the square root of 7, so I leave that. So that's where this 2 is, and this 7 comes from. And then you're going to take the square root of x to the 7th, and we're going to say that equals x to the 6th times x. And what that does is x to the square root of x to the 6th, just like the square root of x squared equals x. I divide 2 by 2 and I get 1. I'm going to divide this 6 by 2 and I get x to the 3rd with no radical sign. And then the square root of x stays behind. And when I combine this and this together, I get this answer here. And this gets I'm sorry, not that answer. I get this answer here. This is a little bit tricky. Okay. Well, let's look at some other examples. So if I have 12 times 32, or square root of 12 times square root of 32, I can multiply them out to equal the square root of 384. And that equals the square root of 64 times the square root of 6, which equals 8 radical 6. So again, this is tricky, still very tricky. Um, so what you want to do is basically when you multiply these together and get 384, you want to see if the perfect squares go in it. Does 2 times 2, which equals 4, does 4 go into it? In this case, 8 goes into it. 3 times 3 is 9. 4 times 4, 16. Does 16 go in it? You want to keep going until you go past values that can't go into it. So again, this is a little tricky. Does 25 go into it? And you have to basically use your calculator. 6 times 6 is 36. Does 36 go into it? 7 times 7 is 49. Does that go into it? And in this case, 8 times 8, which is 64, it does go into it. So if I go on my calculator and I take 384 and I start dividing it, let's say I divide it by 4, or 16, sorry, and it does go into it, but 4 goes into 24, and 4 goes into 24, so more than two fours go into it. So you got to keep trying all the values. Does 49 go into it? No, but does 64 go into it? Yes, it does. Oh, and it goes in 6 times. So that's where we're getting this 64 times 6. And the square root of 64 we know is 8, so my answer is 8 radical 6. So again, that could be very tricky. It's basically the same concept. Now we're going to involve variables and numbers into the question. So I'm just going to multiply 7 times 3. That's the 21 out front. And then 5 times 8 is 40 inside, and x times x is the x squared. Now I need to rationalize this here. Leave the 21 outside, rationalize what's inside here. And here's the work that they do here. I would do it a little bit differently. I would take the square root of 40 and break it up into 4 times 10. Square root of 4 times the square root of 10. And that would break up into 2 radical 10. So that's where they got this 2 here and this radical 10. And then they multiplied 2 times 21 to get 42. We do the same thing with the x. Well, there's nothing to do with the x. The square root of x squared is x. So that's where this x comes from down here. That's a little, again, this is not the easiest thing, but it will get easier as you learn it. Okay, so this example here, there's not too many questions like this that have this difficulty. I'll just show you this example. You can look at it on your own. I'm going to look at the quick checks and some of the questions on the next page. Here's an example of a simpler form here. 3 over radical 7. What we do is we want to rationalize the denominator. So to rationalize the denominator, you multiply the top and bottom by the denominator. So the top turns into 3 times radical 7. And then radical 7 times radical 7, which is 49, which ends up being 7. So this is my final answer with it rationalized. Here's another example. You can pause and look at the video and look at it. I'm going to look at these quick checks down here. Try to get you a better understanding of this. Even these are a little bit more complicated than what we're doing on the homework. But let's go through them. 60. So you got to break this up. You got to figure out what the square root of 60 is and the square root of a to the 7th. A to the 7th is easier. Just divide by 2 and you get 2 goes into 7 4 times. I'm sorry, not 4 times, my bad. 2 goes into 7 3 times. 3 times 2 is 6 with a remainder of 1. So that's where the a to the third comes out and multiplies by a here to get a to the fourth. Again, this gets very tricky. 60 breaks up into 4 times 15, which turns into 2 radical 15. Okay, so what happened here was the remainder of the a stays inside, the 15 stays inside, and out comes the 2 and the a to the third. So this third here turns into a to the third. That gets multiplied by this a, and that's why it's a to the fourth. So again, very tricky. This question is very tricky. Square root of 13 times 52. They just go ahead and multiply this. Square root of 52. Let's see what goes into 52. Well, 2 goes into it, so which is 26. So this is really 2 times 26, and then they're going to multiply it by 13. Radical 2 times 26 times 13. So if you get good at this after a while, you can see that this is another 26, and it's really 26 times 26. But that's a little bit tricky there. That's a little bit tricky to do. So let's try it another way. Let's multiply the 2 together. And we're going to go 13 times 52, and that gives us 676. Well, go right ahead and see if it's a perfect square by taking the square root of 676, and it is. So that's where they get 26 as their answer. So it's good to check to see if it's a perfect square right away. Okay, you can look at the rest of these here, and I'm going to kind of go over a few questions or a few ways to do this, and maybe even look at the homework question. Maybe even. Okay, so let's look at these homework questions here. I got -4 times the square root of -160. I need to break up the 160. Hopefully you can see that that's just 16 times 10. And this is going to turn into 4 radical 10. However, I have this -4 out front here. I need to multiply it with that. So it's going to turn into -16 radical 10. The next question is square root of 144. You can just do that on your calculator, and that's going to turn out to be 12. We'll look at number 3. This one looks a little scary, but, well, h to the 4th, square root of h to the 4th, if I divide 4 by 2, I get 2. So that's going to turn into h squared. So it's probably answer C, but let's look at the rest of it. 180, square root of 180. Let's see, 9 goes into that, but so does 36, I believe. And I wanted to know how many perfect squares go into it. Divided by 36. And it goes in 5 times. So this is really the square root of 36 times the square root of 5, which is really 6 radical 5. So I have h squared and 6 radical 5, and I have a -3, and I got to combine all those 3 to get my answer. So what they do is they do -3 times 6 to get -18. There's your h squared, and your 5 that stays in from the square root. Again, you're going to have to watch these videos and try these problems out. They're not the easiest problems to do. Okay, this one here, I'm going to multiply, so let's just multiply ahead. -4 times the square root of 2 times 22 is 44 times p. Okay, so I can't divide 2 into p to the first, so that p is going to stay inside. So, and you notice all your answers have a p inside except for this one, so that's not the right answer. Now 44, square root of 44 is broken up into the square root of 11 times the square root of 4. Sorry for my handwriting, I'm writing with the mouse. Square root of 11 times the square root of 4. Okay, so that's going to get me 2, square root of 4 is 2, times the square root of 11. So we're going to combine this, the p here, and the negative 4 together, and that's going to get me negative 8 radical 11p, which is this answer here. Question 5, I'm going to just break this up into the square root of 10 over the square root of 81. And we know the square root of 81 is 9, so my answer is radical 10 over 9. Number 6, I'm going to do this similarly to the one I just did. I have the square root of 80 w cubed over the square root of 9. Okay, I know the square root of 9 is 3, so my answer is going to have a 3 in the bottom, or should have a 3 in the bottom. Sometimes it doesn't work out that way. But I got to deal with the square root of 80 and the square root of w to the third. Let's rewrite that, w to the third. Okay, well that breaks up, the w to the third breaks up into w times the square root of w. So it's either a or b. But now I got to deal with this 80 here. 80 is, well, 4 goes into it 20 times, but I think 16 goes into it too. 16 goes into 80. Five times. So this is really times square root of 5. Okay. So this turns into 4 radical 5. Okay, so I'm going to combine this and this together to get my answer, and the 3 on the bottom. And radical 9 is 3. So if I combine all those together, the tops together, I have a w on the inside, w on the outside, and 4 radical 5. It looks like it's going to be letter B for me here. Okay, radical 400 over 5, I can just divide 400 divided by 5. That's going to get me radical 80. I think we just did radical 80. Yeah, we did it up here, but let's do it again. That's radical 16 times radical 5, which is 4 radical 5. So that's letter A. So these are not the easiest questions to do in the world. Okay. This one here looks very complicated, but let's do the division first. 7 into 16, and let's leave that square root aside. 7 into 63 is 9. Okay. X on the bottom with 15 on the top, it turns into x to the 14th. And 9 on the top and 11 on the bottom for y turns into y to the third. No, I'm sorry, y to the second, my bad. Y to the second. 9 minus 11 is negative 2, so y to the second on the bottom. So now we can just break this up into the square root of 9, square root of x to the 14th on top, over the square root of y squared on the bottom. And then this falls apart very nicely. Square root of 9 is 3. Square root of x to the 14th is x. Remember, divide 14 by 2 is 7. And the square root of y squared is divide by 2, and we get just y. So that gives me this answer here. 20, number 10, number 9 and 10 here. This one we have to rationalize the bottom. So we're going to multiply the top and bottom by the square root of 21. So 21. And that turns into 4 radical 21 over 21. And that's as far as we can go with this. That's answer A. This one here, I can reduce this to square root of 100 over square root of 5 is the same thing as the square root of 1 over the square root of 5, or basically 7 over radical 5, and then we're going to rationalize the denominator multiply the top and bottom by radical 5 for radical 5, which equals 7 radical 5 over 5. And that's tricky too. So hopefully you're watching this video and you're able to get this homework done. Thank you and God bless you.